Solutions to term 3 midterm. So let's have a look. I've got a function y equals 2x squared minus 13x plus 15, and I want to differentiate it from first principles. So I'm going to recognize that this is really y of x is 2x squared minus 13x plus 15. Okay, so when I'm trying to differentiate it, I'm trying to find what y dash of x is. And I know that's the limit as h approaches 0 of y of x plus h minus y of x all divided by h. So off to the side, I'll try and figure out what y of x plus h is. So everywhere I see x here, I'll replace it with x plus h. Okay, I'll do some expansions. So I'll remember x plus h all squared is really x plus h by itself. And then I can expand these brackets. So x squared plus 2xh plus h squared. You can do the FOIL expansion if you want and simplify. Okay, and I'll multiply the minus 13 in this step as well. So my y of x plus h is going to be 2x squared plus 4xh plus 2h squared. Okay, this massive expression here. There's lots of terms there. Hopefully some of them will get cancelled out. Now that I've done that expansion, I can come back to my derivative and substitute that result into where I have y of x plus h. So all of that is going to go in this line. It's going to look pretty big. Hopefully my fraction line's long enough. Okay, so that's the first part done. And then it says take away y of x. So I'm going to take away y of x. Since I'm taking away more than one thing, it needs to go in brackets. Okay, so every time I need to make sure I write that limit statement. Okay, and then I'm going to rewrite all of these and expand the negative bracket to those three. So minus 2x squared plus 13x and minus 15. And now I'll have a look along that top line, see if there's any things that are in common that can cancel out. 2x squared and minus 2x squared, they'll cancel. Minus 13x and 13x, they'll cancel. What else is going to cancel? At this point, everything that doesn't have a h in there should cancel. So I've got these minus 15 and minus 15, so it normally indicates I made an error. I'll have a look back at my y equals x plus h expansion, and I changed that plus to a minus for some reason. So all of those should be pluses, and it should be pluses in there, and these two will cancel. So I'm left with, that was just a demonstration for how to problem solve when you get stuck in exams. Left with this expression. Okay, from here, I recognize that on the top line, there's a common factor of h. Now I'll write what's left over when I take that common factor out. And now I can cancel these h's as long as h never actually gets to 0, which will pretend that it never does. Even though I'm now going to substitute in this h equals 0 into this expression. I'm literally now going to forget writing the limit, just put a 0 in there, and I'm left with 4x minus 13 is my y dash of x. Some people feel more comfortable using the f of x notation all the time. So pretty much wherever you see the y's, you can just replace it all with f's, if that makes you more comfortable. How can I check that my answer is right? Well, I can just differentiate this guy from first principles. I'll know it'll be 4x minus 13. Correct, differentiate by rule and see that I get the same as what I would in this answer. Okay, so that's the way you can check. So differentiation by rule, the main rules you need to remember, if I'm differentiating something like 3x squared, okay, I'll multiply the power by the number at the front, so 3 times 2 gives me 6, and then reduce the power by 1. So it was 2, now I'll write a 1 there, probably leave that off. If I have a term like 4x, the derivative will just be that number, because it's a linear term. 4x, that's the gradient all the time. And the derivative of just a number like 7 would be 0, because it's a flat line. So keeping these rules in mind, we'll differentiate these guys. So it's a y equals, so I'll write y dash, 3 times 5, 15, reduce the power by 1. Minus 4 times 2 is minus 8, reduce the power by 1. And now we've got a linear term, there's really a 1 there, I'll add 1. That's all the working that you need to show. For part B, I don't have these just normal linear terms or polynomial terms one after another. So before I differentiate, so before I change this to f dash of x, I need to expand here. 6x squared minus 2x to the power 4. Now that I've got terms like this, I can go ahead and differentiate 12x minus 2 times 4 minus 8x cubed. If the powers are negative, that doesn't matter as long as my variable x is on the top of a fraction. I can go ahead and differentiate. To mix it up, I'll use dy dx. 3 times minus 5 minus 15 x to the power minus 5 minus 1. I normally wouldn't do this in 2 steps, but minus 5 minus 1 is minus 6. And generally, we don't like to have negative indices, so we'd put that x to the power minus 6 down the bottom as x to the power 6 in our answer. Make sure we state that it's dy dx. Okay, part D. This time I've got the variable underneath the fraction line, so I might need to do some work before I can differentiate. So all I'm going to do is bring this x squared up to the top of the fraction, just the x squared. So the 1 on 5 would still stay the same, and x to the power minus 2. So my derivative now will be, well, minus 2 times the number out the front. 1/5 is the number, so I'm really doing 1/5 times minus 2. Give it a denominator of 1 because it didn't have 1. Minus 2 on 5 is the new number out the front. Reduce the power by 1. Minus 2 minus 1 gives me minus 3 as my power. Again, don't like negative powers, so I'm going to bring this x to the power minus 3 down to the bottom of the fraction line and give it a positive power. Okay, so that's what my g dash of x looks like. Final one is 2 times square root of x. This is 2 times x to the power of a half. If I had cubed root of x, it would be x to the power of a third, etc. So to differentiate, just the same rule as always. 2 times a half gives me 1, and then reduce the power by 1. So a half minus 1 is a half minus 2 on 2, or negative a half. So I've differentiated now, so I better change this to dy dx. And I don't like this negative power, so it's 1 on x to the power of a half, or I should really simplify it to 1 on square root of x. Key thing for a C and J perspective is here I'm just changing what it looks like. When I actually differentiate, it changes to g dash, or changes to dy dx, or y dash, or f dash, or whatever. Question 3, find the equation of the tangent at x equals 2 on this curve. I think I can do that. Okay, first of all, I need to find the gradient of the tangent. Okay, the way I'll do that is I'll find the general gradient, or the derivative. So I know that y dash would be 2x minus 4 is 0, so just 2x. Okay, the gradient of tangent at x equals 2 will be y dash of 2. So 2 times 2 will give me 4. So this is the gradient of my tangent. To find the equation of the tangent, so at the moment, this is what the thing looks like. The point 2 is probably here. All I know is that this line has a gradient of 2. I don't know the equation of the line yet. To find the equation, I'll need to find the coordinates of this point. Okay, so I need to find a point, and I'll do that by subbing in x equals 2 into the original equation to find how high that point is. So 2 squared minus 4 give a y value of 0. So I know that 2, 0 is a point. Okay, so from here, I'll sub in m equals 4 and the point 2, 0 into y equals mx plus c, and hopefully I'll be able to find the c value and we'll be good to go. So 0 equals m is 4 times 2 plus c, 0 equals 8 plus c, my c value is minus 8. So I know gradient is 4, c value is minus 8. You can sort of see it coming down here to some negative value. So the equation of the tangent will be y equals 4x minus 8. Okay, so trying to do question 4. Okay, question 4, the volume of the tank is being filled by this function, where t is time in minutes and v is the volume in liters. Find the rate of filling after 5 minutes. Rate of filling means what's the change in volume versus the change in time, or what's v dash of t. Rate of filling after 5 minutes means what's v dash of 5. Okay, or in the other notation, dv dt when t equals 5. So the function I have is 1200 plus 1020t minus 17t squared. Need to find what the derivative is. So differentiating 1200 is nothing, differentiating 1020t is 1020, and minus 17t squared minus 34t, and then I need to sub in t equals 5. So v dash of 5, 1020 minus 34 times 5 gives me 850. What are the units? Well, the volume is in liters, so it's liters per minute. And because my graph would be volume versus time. Minutes and liters. A final question brings in a lot of your skills. Electron emission from a particular service that's exposed to radiation, something, something, something. Here's your provided equation. Okay, find the frequency, F, for the greatest emission, E. So we're trying to maximize E. we've got a formula for E, so we'll just go ahead and try to find where the greatest emission will be. Okay, I know that maximum will occur when the derivative equals 0. So I'll try to do that. I'll try to differentiate it, set it equal to 0, and find where these f values would possibly be. So my derivative is 3f squared minus 30f plus 72. If you struggle to do that, go back to question 2. Now we're going to set the derivative equal to 0. And try to find which f value satisfy that equation. There's a little trick here. If you just try to factorize straight away, you'll have 3f and f, and you'll be trying to think of numbers here that multiply to give 72, whereas where on the cross you'll get a negative 30 as well. A trick is that you can take out a common factor of 3. It's 24. And then you can divide both sides of the equation by 3. So the left-hand side still ends up as 0, and we're just left with this simpler expression to try and factorize and solve. So then I'll have my f's to get f squared. Think of two numbers here, multiply to give positive 24, and add to minus 10. I think there'll be minus 6 and minus 4. So that'll be my two factors. So f equals 6 and f equals 4. They're going to be my turning points. I'm not sure if they're maximum or minimum yet. I need to find what the other coordinate is. So I need to find what e of 6 is and what e of 4 is. So I can actually talk about a point rather than a line. Okay, so I'll sub these both into my original equation up here. So I get to this stage where I now know that 6, 8 and 4, 12 are stationary points or turning points. And the next step is to do a classification on both of these. Okay, so I'm just going to use the table method. If you're comfortable using second derivative test, go ahead. So I'm going to look at, for these f values, what is the e dash of f? So what's the slope at those values? So I'm interested in what's happening around f equals 4 and what's happening around f equals 6. And I'm going to complete this table. I'll put 5 in between these two guys, and I'll just use some basic numbers around there. So I'll evaluate the slope. Remember my slope function. I'll just do one demo. E dash of 7 would go here. From this slope function, 3, 7 squared minus 30 times 7 plus 72. So I found all these slopes. So my slope diagram would look something like this. So I know that 412 is a local maximum. Yeah, that looks like a maximum to me. And 6, 8 is a local minimum. Okay, this won't necessarily be my answer. To find the greatest value, I also need to look at the domain endpoints. So between 2 and 7, I'll make a little table to find what is the emission at 2 and at 7 and at what I think the maximum is at 4. Okay, so I'll substitute these values into that original function and see what 2 and 7 give me. So I've substituted in, I found the values at the endpoints. So remember, these two are the endpoints, and this is the max, or the local max. So I'll see that at f equals 4 and f equals 7, the emission is greatest. Okay, the value is 12 over the domain between 2 and 7. Normally there'll just be one maximum and you'll state that one's the maximum. This one's a little bit special. All right, done.